Welcome to a comparison video on the topic of NMR spectroscopy and MRI. These methods utilize the principles of nuclear magnetic resonance to provide valuable insights into the structure. Join us as we delve into the world of NMR spectroscopy machines and MRI systems to understand their similarities, differences, and applications. Spectroscopy is a technique used to study the structure and properties of molecules. It involves the interaction of atomic nuclei with a strong magnetic field and radio frequency pulses. NMR spectroscopy provides information about chemical shifts, spin-spin coupling, and molecular dynamics, enabling researchers to analyze molecular structures and understand their behavior. Now, let's move on to MRI, which stands for Magnetic Resonance Imaging. MRI is a medical imaging technique that utilizes the principles of NMR spectroscopy to visualize internal structures and organs in the human body. It uses a strong magnetic field and radio frequency pulses to generate detailed cross-sectional images, providing valuable diagnostic information for various medical conditions. The principles of operation for NMR spectroscopy and MRI are fundamentally the same. Both techniques involve the application of a strong magnetic field to align the spines of atomic nuclei within a sample. Radio frequency pulses are then applied to excite the spines, and the resulting signals are detected and analyzed to obtain relevant information. However, the applications and specific setups differ between NMR spectroscopy and MRI systems. NMR spectroscopy finds extensive applications in chemistry, biochemistry, and pharmaceutical research. It enables scientists to identify and characterize molecules, study reaction kinetics, and investigate protein structures. MRI, on the other hand, is primarily used in medical diagnostics. It helps physicians visualize internal organs, soft tissues, and detect abnormalities or diseases, aiding in the diagnosis and treatment planning process. One notable difference between NMR spectroscopy machines and MRI systems is the magnetic field strength. NMR spectroscopy typically operates at lower field strengths, ranging from a few hundred MHz to a few GHz, depending on the desired sensitivity and resolution. In contrast, MRI systems operate at much higher field strengths, typically ranging from 1.5 Tesla to 7 Tesla or higher, to obtain detailed anatomical images of the human body. Another difference lies in the sample types and preparation methods. In NMR spectroscopy, samples can be in liquid or solid form, with various techniques available for sample preparation. The samples are typically contained in NMR tubes or solid-state rotors. In MRI, the samples are living organisms or human patients, and no special sample preparation is required apart from patient positioning and safety considerations. Spatial resolution and sensitivity are important factors to consider. NMR spectroscopy typically has high spectral resolution, allowing the identification and quantification of individual chemical components within a sample. However, its spatial resolution is limited, often in the millimeter range. MRI, on the other hand, offers excellent spatial resolution, enabling visualization of structures and tissues in fine detail, but it may have lower spectral resolution compared to NMR spectroscopy. Safety is of utmost importance in both NMR spectroscopy and MRI. NMR spectroscopy is generally considered safe for samples and researchers, with minimal risk associated with the magnetic field and radiofrequency radiation. In MRI, patient safety is carefully ensured. Precautions are taken to screen patients for potential contraindications, such as the presence of metallic implants or devices that could be affected by the strong magnetic field. NMR spectroscopy and MRI share the same underlying principles of nuclear magnetic resonance but differ in their applications, sample types, preparation methods, imaging techniques, and time considerations. Both techniques have significantly advanced scientific and medical knowledge, enabling researchers and physicians to gain valuable insights into the molecular and anatomical realms. We hope this video has shed light on the similarities and differences between these two fascinating techniques. If you found this content informative, please give it a thumbs up and consider subscribing to our channel for more exciting science-related discussions. Thank you for watching, and until next time, keep exploring the wonders of science.